Welcome back to the ARC Agency's formal CPD webinar series and our second session for the day. It is lovely to have you all join us. For those whose first session this is, my name is Brooke. And on behalf of the ARC Agency, as well as today's presenters and their behind the scenes team, I would like to thank you all for attending. As mentioned in our previous session, if you are joining us for multiple, you will hear me repeat myself. Our recommended steps for success today. You must be registered for each session you wish to attend. Please check the chat for invite details should you wish to add any extra for the day. Included in this link, if you have not done so already, please download the appropriate questionnaires for the presentations you are attending. Each session does run for 1 hour and sessions will start on time with access closing 5 minutes after their commencements. Your CPD certificates will be issued by our presenters and recordings of the session will be made available to watch again following today's wrap up. We encourage you to ask questions via the Q&A function, which you will find at the bottom of your screen in the black control ribbon. Each session has technical specialists on hand to answer your questions live. As part of the formal assessment and guidelines, each presentation includes a questionnaire which you are required to complete and is to be kept for your own records. Please note, if you are after a CPD certificate and have joined us as a team or on someone else's invite link, please let me know so I can allocate your certificate accordingly. Please email me, brooke@thearcagency.com.au. I again would like to thank you all for joining us, and may I present our second webinar session, Network Architectural Durlum, introduced by Stephen Fraser, Modern Ceiling Systems and Healthcare. Thanks, Stephen.
Thanks, Brooke, for that introduction. So hello again. My name is Steve Fraser, and I'm going to be with you for the next 45 minutes to impart some of the knowledge and experiences that I've gathered in 10 years of working within ceiling manufacture and design. So in that time, I've worked on delivering ceiling systems for multiple multi-million-dollar healthcare projects across Australia and New Zealand, including the Royal Adelaide Hospital, which had the distinction at the time of being the world's third most expensive construction project. It cost over $3 billion to construct, and ideally after this presentation, you'll be able to design a modern hospital ceiling that comes well under this budget. We will cover topics such as the journey and steps involved in how hospitals are designed and built, the origins of modern hospital design theory, learnings gathered from design research and post-pandemic findings, and the latest material options for healthcare ceilings. Here are some of the learning outcomes and a list of the performance criteria that we will cover in this presentation. We will also, at the end of a topic, refer you to a question and you will be asked to record an answer for your CPD points. So please pay attention to these questions at the end of the topics. And if there is any dramas with answering the questions, please just jump up on the chat and reach out and we can help you with that. First section we'll be looking at is the process involved in designing a hospital. So every government-funded healthcare project above $10 million follows this design process path. They're controlled by state government departments. My local example of this is Health Infrastructure New South Wales, and the 3 main phases are the planning, design, and delivery phase. So in this CPD presentation, we're going to take a look at the planning and design stages of this process. Clinical service plans are at the very start of our design journey, and they are developed by local health boards and formulate planned usage for healthcare projects for the next 10 years. The plans use data such as current health data, census information, future needs projections, and such as the change in the demographics of Australian society. So up in the slide here, we have some interesting facts about the demographic shift of the population of Australia. So as of 2021, there are 500,000 Australians over the age of 85 years old. By 2050, that number is forecast to reach 1.28 million, which is about 5% of the total population. The next stage, we engage user groups and stakeholders to come up with a concept design and a master plan. These demonstrate the relationships between the clinical function services and building facilities, both vertically and horizontally. So one project which I worked on in Western Australia was Perth Children's Hospital, and we came up against a unique challenge, and this came up in the concept and master plan stage, was that if you can see in this image here, we've got a helipad which is sitting on top of the hospital, but the designers decided to put a children's creche right underneath the helipad. So we had a few issues with CASA, the Civil Aviation Authority regulations, with having aircraft taking off and landing right beside children. So we managed to solve the acoustic problems the acoustic challenges that would raise. But we also had to redesign a few areas of the outdoor areas where the kids could play, not somewhere underneath the helipad. Next section of the journey is the business case and project business case. So this determines the scope of works, the project ceilings budget. In New South Wales, I'll use this as an example, the government locks in this funding over 5 years, and this is a result of their overall clinical services plan. So in the next 5 years in New South Wales, we've earmarked $11.9 billion for hospital projects, and this is over 130 different projects. The next phase in our design journey is the schematic design. Now, I have some images up here on the screen of some RCPs of the Nepean Hospital, and a photograph on the left, which I took of one of the ceilings in Nepean Hospital too. So as you can see on the RCP drawings here, there's no sort of mention of the services. And when we're designing ceilings in hospitals, the actually biggest problem that we face is clashes between all the services that are required to keep the hospital running and how we're going to install the ceilings. So this image on the left shows you that there's absolutely zero space in the ceiling plenum to suspend any of that T-bar grid system that we have specified on the RCPs. So what I'm trying to say is at the outset, the schematic designs are very useful to have conversations with other stakeholders like the ceilings and the Met guys to try and see if there's simpler solutions. The simplest solution in this case would have just been to have changed the ceiling from a standard modular T-bar grid system and use a plank system to run across. But because we didn't find out about this clash until we were actually on site and we're actually in construction phase, we didn't have the lead times to get the system manufactured and fabricated from the factory. So I'm just going to put it out there to some people in the comments. So how do you think we could rectify this situation? So I'm just going to take a moment to pause, and if you can put some ideas in the chat, we'll get back to that. So ideally, what the solution was, and it was quite an expensive solution, was we had to put some cross-member beams across underneath the services to essentially build a bridge underneath it. So it went through the partition walls and then got to a point where we could find access to the ceiling plenum. So that's quite an expensive way to build a substructure to put in a ceiling, when we could have just at the design phase put in a completely different plank ceiling with splines that would have bridged the walls, and we could have got away with that. The next and last phases are detailed design elements of healthcare ceilings. So colors have a massive, massive impact on patients' well-being, and they've notified that clear wayfinding reduces stress when you're in a hospital, and the use of colors for distraction can alter people's moods when they're not feeling great in hospital. Traditionally, white is used for ceilings due to its light reflection and also that it shows up dirt. But that doesn't need to be the case now with modern ceilings. We can be a little bit more adventurous and use a different color palette from just white. Now we're going to discuss the evolution of healthcare and design. So there's been a great shift of building institutional type white interiors of buildings. And we use an evidence-based design approach now, which uses scientific framework where we can measure the effects that designs have on people and the building's impact it has on the end user. Scientific data shapes our style of design of future hospitals, with biophilic principles at the forefront due to the positive impact they have on building users. We're also going to talk about new technology, which is driving design too, such as remote patient monitoring, as devices such as smartwatches on your wrist are managing to move people out of hospital, lessening the crowding and gathering of people in hospitals, which has the effect of less spread of infection through contact and less sort of traffic in buildings, less stress on the infrastructure that's required. So doctors need their workplace to have superior acoustic spaces to allow telehealth sessions with remote offsite patients. And this is real important now that we design hospitals not only for the acoustic comfort of the people inside the building, but also to facilitate telehealth and that sort of progression of technology. Nanotechnology is also helping with digitizing labs. So we can have microchips now that act as pathology labs, which means we don't need dedicated space or so much dedicated space for pathology laboratories. And the ability to handle this kind of data, information and load is requiring our hospitals to have 5G capabilities of communications and adaptive networking capabilities that's paramount to the integration of future designs of hospital and healthcare facilities. So we're going to recap and go over a few questions here. What percentage of the Australian population in Australia will be over the age of 85 years in 2050? So is it going to be 2% of the population, 5% of the population, or 10% of the population? So we'll just take a little pause here and have a think about this question. Now, if there's any questions, feel free to pop it in the chat. So future hospitals, an example of the change of hospital design over time. I have the case study here of a new hospital in Istanbul that my company Durlum supplied some ceilings for. This is the Memorial Baklava Hospital in Istanbul. And this building achieved a platinum LEED rating, which is equivalent to a 5 or 6 Green Star rating here in Australia. And it shows that the building can emit less carbon during its construction phase and operations. It's also very water efficient, and it has improved air, light, acoustics, and product finishes. And you can see by the images up on screen here, this hospital looks more like a five-star hotel rather than a clinical facility. The next sort of images we're going to show is the lobby and foyer area of the hospital. It's designed on biophilic principles, having a large open area to allow natural light in. And the doctors' consultation rooms are also designed for diagnosing patients remotely with telehealth. So you have massive focus on infrastructure of acoustics and lighting to be able to facilitate these teleconferencing medical appointments. Next question. So what will be the critical infrastructure that is required in hospitals of the future? Is it going to be digital infrastructure, hydrotherapy pools, or larger ICUs? So we can take a moment to think about that particular question. So healthcare design is not a new concept, but one of the most famous proponents of healthcare design was a 19th century lady by the name of Florence Nightingale. So she was well known for being the pioneer of modern healthcare design in nursing. But not only did she establish the concept of modern nursing, she was a very good proponent of using evidence-based research to come up with their design ideas. And she was a good proponent of biophilic design. Florence Nightingale introduced the spacing of patients' beds at 1 meter apart, and also came up with the concept of natural ventilation and light, which are key tenets of biophilic design that we still use to this day. And she was a very big statistician, and this is an image of one of her pie charts, which was actually quite a new innovation of her time. And she used lots of graphical data to present to her peers. So we can thank Florence Nightingale for the path of biophilic design. So what is biophilic design? So biophilic design ties industrial structures to the natural environment. And biophilia is a theory that humans have a natural urge to engage and be in nature. So I don't know if it's just me because I'm into ceilings, but by all my social media and all my feeds came up popping with these images of ceilings with printed images of exterior or clouds and things like that. But printed images, I think, are a bad way to go because printed images always look out of place and fake due to the composition being out of context. And with biophilic design, context is actually key with its environment, and also the quality of the image in printing is usually poor in these sort of SoundCloud printed images, and then the human brain just picks it as being out of context. So they don't really work, these sorts of things. So biophilic design is, as we've touched upon, is the human attraction to nature. It's a concept that's been recognized for several decades now by the scientific and design communities, and intuitively by hundreds of years by the population at large. Biophilic design has often been regarded as a luxury for property owners who want the best possible workplaces for their employees, or who want to showcase their efforts to be more environmentally responsible. In reality, though, improving community well-being through biophilia can impact patients' health and staff productivity and amortize these upfront costs over the period of the building. So the effects of a building are felt long after the cost is forgotten. And I think this is our responsibility as designers to promote this to building user stakeholders. So I've got to do a little case study here of a project that our company did in Hong Kong. And this was a children's hospital, the Center of Excellence for Pediatrics for Children in Hong Kong. And this was built around some theories of biophilic design. So all patient rooms within this buildings have large windows with views that allow natural light and a connection to place with views of the harbour of Kowloon. So most of the patient bedrooms have water views into the harbour. The ceilings in this particular hospital also have 95% light reflectance to allow the natural light to reverberate around the room. And these ceilings also actually have the technical ability to be airtight. So the second section of this hospital here was actually constructed during COVID, and all of the ceilings in this hospital are airtight ceilings, which will go through some diagrams of how they were constructed. So this is a typical detail of an airtight ceiling. It's actually quite a simple ceiling when you think about it. It uses standard T-bar subframe grid and an A carrier rail. And the panels are designed to have little tabs that clip into this A-frame locking mechanism. And they're installed really simply. They just get pushed into the A-frame, and then they have a little locking clip that locks the panels in. And around the panel, we have a compressible gasket seal that goes around the panel, which stops any air leakages traveling from the room into the plenum space. And having airtight ceilings are useful for a couple of reasons. So negatively pressurized rooms is one example. So we use gasket sealed ceilings in negatively pressurized rooms. So where we would use negatively pressurized rooms is for patients that need isolated. So they generally have contagious diseases such as coronavirus, tuberculosis, chickenpox, and simple things like measles. So essentially what we're trying to do here is to keep the pathogens that the patients have within that space. And what we do is we introduce air pressure into the room, and the air pressure is then extracted through filters. But it's very important that we don't allow that air to escape into the plenum space. The other type of room where we would use a pressurized and sealed ceiling is in positively pressurized rooms. So this has slightly different purpose. We use positively pressurized rooms as where you want to keep pathogens from entering the space. So that would be useful for patients that are, say, immune compromised, have just come from post-operation, or have just had a treatment of chemotherapy. So the idea here is we put air pressure into the room, and that causes a positive air pressure, and that stops pathogens from entering the space. So we also need to, as I say, have our pressurized ceilings here. Now, there's a little table here called the ACH. There's actually tables for the amount of air changes we have per hour. And if this can get a little bit technical, so if you have any technical questions about negative and positively pressurized rooms, please feel free to contact me at the end, and we can definitely go through it all. There's guidelines of different standards of positive and negatively pressurized rooms, and these are classed as S, P, N, and Q, and they're all designed for different infections and different types of diseases. So as I said before, any questions on this, please feel free to get back to me. Another case study when we talk about biophilic design is there was one project in Sydney, St. George Hospital. So biophilic design also has a connection with country and place. And the architect that was designing a refurbishment of St. George Hospital wanted to connect the local river, the Georges River, and somehow connect that into the building. So the idea was thinking that the entranceway, we could build a soffit that mimicked the flowing water of the Georges River. So the ceiling system we came up was a panelized suspended exterior ceiling system made of aluminium, and we coated it in a sort of electroplated coat to mimic the shimmery of the water and to copy the St. George's River. So that adds a bit of connection to local place from the hospital to its local environment and to country. Another hospital project we're introducing some biophilic design using metal products was Footscray Hospital down in Victoria. Now, we're still very much at the concept phase of this, but the idea is that we would have some curved timber battens. Now, timber battens is the look that the architect was going for, but they weren't happy with the sort of maintenance schedule and the amount of maintenance that timber would require. So we could offer some aluminium and steel solutions that mimic some timber. Now, timber and metal, it's obviously the materiality is a little bit different, but we can actually come up with some unique solutions where we can curve the grain. So sometimes printed wood grain on metal looks a bit fake because the grains in timber don't marry well, but Durlum have got good techniques of bending the grain to follow curves of timber, so we get a natural look within the timber metal battens. So we're going to recap and go over a few questions now again. So what type of data did Florence Nightingale use to develop her theories of nursing? Was it visual cues, statistical data, or clinical research? Now, bearing in mind that Florence Nightingale loved mathematics, so that might give you a clue to that one. The next question, question 4, is can you name 3 elements of biophilic design? So thinking about biophilic design, what's the idea? There's obviously nature, light, air, those sorts of natural elements. Can you name 3 elements of biophilic design? So the second section we're going to discuss is post-pandemic ceiling design. And if COVID-19 taught us anything, was that modern healthcare facilities need to be flexible and to cope with quick changes. Now, I'm going to do a few case studies here about some international examples. So one recent example of flexible designing and building was the appropriately named Nightingale hospitals that were built in the UK. So these were emergency field hospitals, which were 14 of them were built in total. And they were fabricated from absolutely nothing, in some cases from zero to fully complete within 2 weeks. And they were built in existing infrastructure, such as conference centers, train stations, any sort of large area which we could handle multiple people. And they were actually built using the British Army engineers to construct them. And yeah, a lot of these were managed to be fabricated within 2 weeks. Their intended purpose was to leave the existing hospital capacity for the really, really sick, and then use these hospitals as an overflow to treat mildly ill COVID patients. But thankfully, all in all, only 1,000 patients were ever treated in these 14 hospitals throughout the UK, as the existing NHS infrastructure managed to cope with the demand, partly due to the lockdowns and strategy of mitigating the disease. So the majority of these facilities were decommissioned pretty quickly after they were constructed and converted into mass vaccine centres, so they weren't completely a white elephant. This is an extreme example of necessity over design. And if we look at the sort of the flow of the design of this was the Excel Nightingale Hospital in London. It was in a conference centre, so very simplistic. It had a simple design. Patients come in, their admissions, they're sort of assessed, then go to their bed, and then once they're in their bed, they're a recovery area and discharged. Now, one particular Nightingale hospital was in Manchester, which was built. This one was actually put forward for award. It was created inside an old train station in Manchester Central Station, which was more used to hosting nightclub and parties and events than it has to be a hospital. But the amazing thing about this is that it was designed by BDP architects and built by McAlpine contractors and the British Army, and they managed to construct it within 13 days. Now, The biggest flaw of this whole system wasn't the actual buildings themselves. It was the amount of staff that was required to man them. So they were never actually fully operational. The British government tried to get old airline crew and hotel staff to man them, because there just wasn't the medical staff. So a lot of them didn't actually see any patients. And they ended up costing £500 million to construct. But it just goes to show you what can be achieved when you put your mind to it. One project that was actually built pre-pandemic, but I'd like to highlight, was designed by an Architects Design Inc. And this was a community-based health centre in Ballarat. So their concept was a whole-of-life design concept in this health clinic, based on the benefits of interaction with nature and community. But it really illustrates the point of multi-use spaces. In addition to full on-site suite of doctors, of dental, of medical services and office facilities for over 100 staff, the centre also included a gymnasium, a cafe, conference facilities, and meeting and event spaces for the community to use at large. And this was all designed around a central atrium, which uses biophilic design and lots of natural light to make the central atrium space. So it's one case study that I'd like to highlight. And also innovative use of space by putting like a kids' play area underneath stairs. So we have a case study here of a hospital in Bavaria in a place called Paderkirchen. And this was a study we did using natural light into the hospital environment. So the key findings here were that light impacts human health and performance by enabling the performance of visual tasks, by controlling the body's circadian rhythm, and the actual light affects people's mood and perception. And they did actual tests on this particular hospital. And Durlum managed to introduce lots of little circular light pipes within the ceiling place of the central atrium to allow this natural light to come through into the space. So natural light is an important factor in controlling the body's circadian rhythm, and light impacts our outcomes of healthcare settings by reducing depression amongst patients. And it also decreases the length of stay that hospital patients have within hospitals, and it improves the patient's sleep patterns. Another example of how we can use natural light is this. This is actually a subway station in New York that we designed. So the subway station is subterranean, underground, but we still managed to get some natural light into the platform area by building these huge light tunnels. So the use of natural light inside buildings has many benefits that we've gone over. So it lessens the agitation amongst dementia patients. It eases pain and actually reduces the amount of pain medication that patients in hospitals require. And one major user group is that we haven't really discussed so far is the caregivers, the doctors and nurses that work in the hospitals. So natural light can also improve the adjustment to these care workers when they do night shifts. So that changing of working days and nights is actually improved by tenfold by having the introduction of natural lights in their working environment. Another example of some innovative technology in ceilings that we've done to get natural light. This is actually an airport, but it's in Singapore's Changi terminals. We have these butterfly ceilings which open and close and allow natural light at different times of the day to come into the terminal. And the idea behind this was to improve passengers' jet lag and improve their circadian rhythm. So depending on the height of the sun, we can adjust these butterfly opening ceilings and close them. And we can also control the temperature of the space as well by increasing and reducing the amount of natural light. So at peak midday, we can close the shutters a little bit to allow a little bit less light in, to still allow natural light in, but also control the load of the air conditioning systems within the building. Another thing that we need to touch upon in healthcare environments is artificial lighting, because that's a really important part of ceiling design too. So good lighting can reduce the number of clinical errors that staff make in hospitals. And studies have shown that pharmacists make 2% less dispensing errors in areas that are illuminated with light above levels of 1500 lux. And also one major important driver of lighting design in hospitals is the positioning of lights. It's important to recovering patients that have just come out of post-op, that they don't have flashing lights that they see when they're getting wheeled on a trolley. So the design thinking now is to put lighting strips along the side of corridors on these images here on the right-hand side of the ceiling. So the picture at the top left just shows standard strip lighting. So that wouldn't be very good for a patient that's just come out of an operation to have this sort of blinkering effect. So the modern design trend for hospital corridors is to have the lighting along the side. Now, one major advantage of metal ceilings is that you can custom design the lights to fit completely and integrate them in with the metal ceilings. So in this slide, we're going to talk about how ceilings affect well-being. So acoustics and noise and its control impact our physiology and is one of the most critical elements where ceilings can affect our well-being. The ceiling is the best place to control this due to its large open surface area above our heads. Now, some of the effects that the noise above 65 decibels can affect our body is that it can induce your body to produce the fight or flight hormone, cortisol, and adrenaline. It also increases your blood pressure. It can increase strokes and sleep disturbance and fatigue if spaces are too noisy, which you can lose concentration, and it can also affect your body's production of insulin. So the World Health Organization recommends that hospitals should have noise levels of not above 35 decibels during the daytime, and hospitals in the evening should have noise levels of 30 decibels. Now, most hospitals' sound, which has been tested, the sound levels are above 60 to 70 decibels. So they're already above the recommended guidelines by about double, and all these sort of effects of sound affect it. So it is really important to get the acoustics right in hospital environments. So we're going to talk about materiality and well-being, surface hygiene and interrupting the chain of infection. Infection control in medical spaces is one of the fundamental priorities when we're designing and building a hospital, and ceilings, at the very least, should prevent pathogens from growing on the surface and actively control the stop and growth and spread of microorganisms such as bacteria, fungi, and yeast. So by stopping these organisms on the surface of the ceiling, you prevent these from getting airborne and infecting other parts of the ceiling and building. So it's very important when we're specifying products to make sure that the products don't aid the spread of infection. So this next section, we're going to talk about materiality and modern ceiling solutions for healthcare and understanding the different types of ceiling solutions that are out there. We're going to look at their advantages and disadvantages, their life cycle costs, the recyclability of each product, and their environmental impacts, which each product has. So the first type of material we're going to talk about is metal ceilings, mostly steel and aluminium. So the biggest advantage of using a metal ceiling system is that they're generally moisture and mold resistant and antibacterial in nature, due to the fact that there's absolutely zero nutrients on the surface of a metal ceiling that bacteria can thrive off of. And also viruses as well have nothing to replicate on the surface of a metal ceiling. Metal ceilings are also really good at acoustic absorption. With some insulation behind, you can achieve up to like the highest sort of acoustic absorption possible, like a 1 NRC. And another thing about metal ceilings is that they have a massive lifespan. You can actually get a good 20 to 30 years of lifespan, and the ceilings still look as good 30 years down the track than the day they were installed if they're maintained. And when we're talking about the lifespan of a ceiling, when you look at the fact that you do get 30 years use out of it, you actually save an average 47% over the life cycle of using a metal ceiling over other materials that will need to be replaced many times in that 30-year period. Another major benefit of metal ceilings is that they're serviceable. You can actually take ceiling panels out, refabricate them, repair them, and reinstall them. And they're completely cleanable. You can take them out the back, hose them down, and then put them back in, and they'll still be absolutely fine. The other major advantage with metal ceilings over anything else is that they're really flexible with their service and light and design integration, and you're not limited to just single module white squares. So you're super flexible with lighting and also the overall aesthetic. The finishes are infinitely customizable. You can have any single color you want. And another major benefit of metal ceilings is they're 100% recyclable at end of life. Now, probably metal ceilings are one of the only building products out there which people will pay you to remove them. So you know that they're going to be recycled and used elsewhere. They're also, their aesthetic value also improves interior spaces, and they just look a step up, a notch up from other products. One thing that we have to mention is the fire resistance. So all the products that we'll talk about throughout this section, they all have Group 1 fire ratings. So they all are fire resistant. Some disadvantages that we need to discuss about metal is that they are very expensive initially. So the average cost of a metal ceiling in a hospital environment would probably be north of about $90 a square meter for its supply only for the grid and the ceiling tile. Now, that might sound initially quite expensive, but as we've discussed, over the lifespan, if you do get 30 years of continual use out of the product, it does amortize over that 30 years to be quite good value. One other disadvantage of using metal ceilings is its low acoustic attenuation. It's not very good at blocking sound, so you do need to have some insulation above that and introduce a second product to dampen sound from spreading to other areas of the hospital. And I suppose one other major disadvantage of metal is its high CO2 emissions and energy consumption and fabrication and manufacture. But as we said before, that can be offset by recycling it into something else. And 9 times out of 10, you would use 50% recycled material to fabricate the panels anyway. So that CO2 emissions can be offset that way. So the next product that we're going to discuss in healthcare environments is mineral fiber ceilings. So the biggest advantage that mineral fiber has is its low initial cost per square meter. It's a relatively cheap initial outlay of $40 a square meter for a high-end ceiling tile. And within mineral fiber, you get a good balance of acoustic absorption and attenuation. Mineral fiber ceilings are pretty cheap and easy to install and replace. If there's a damaged tile, you just need to pop one out and you can pop one back in. They're also really easy to access for plenum spaces as well. So in those previous slides where we showed you all those services running in the plenum space, mineral fiber tiles are really easy to remove. You just pop up the tile, drop it down, and you get access to the plenum space above the ceiling tile. Recycling is possible for mineral fiber, but it is a bit of a process to recycle mineral fibers, ceiling tiles. They're essentially, main component of mineral fiber is clay and mineral wool, which acts as the sort of reinforcing to give the panel its structure. So mineral fiber ceiling tiles can either be recycled into other mineral fiber ceiling tiles, or they can be recycled into bricks due to their high clay component. Now, one good thing about mineral fiber is that because it's clay, it has a high fire resistance, and it does also achieve its Group 1 rating. Now, mineral fiber ceilings are capable of being waterproof and achieving an RH 100. So that stands for relative humidity 100, so 100% waterproof. And cleaning is possible on some ceiling tiles. Now, mineral fiber does have a few disadvantages. So the usable lifespan of a mineral fiber ceiling in reality is probably about 10 to 15 years. And in saying that, mineral fiber ceiling tiles can get easily water stained and damaged quite easily because they're quite fragile. They are just sort of light clay bricks. One big problem with mineral fiber that we have is tea staining. So what happens is that you get a little water leak or a water drop hitting the surface or the back side of the panel, and the binding agent in the panel is actually cornstarch, and it releases tannins, and you get this brown mark appearing on the ceiling tile. So that doesn't happen with other products, just mineral fiber, and it can make the ceiling quite dirty over time. We are limited in its actual aesthetic design by a modular design of just rectangles and squares. So the disadvantages of mineral fiber ceilings is that we're quite limited in the colors and the aesthetic finish that we can achieve with the ceiling. Now, I alluded to an advantage that we can recycle these mineral fiber ceiling tiles, but it is actually quite a difficult process. The ceiling tiles need to be packaged up, all labeled, and sent back to their origin of where they were manufactured. Now, most high-end mineral fiber ceiling tiles are manufactured in Germany these days, and some are manufactured in Asia as well, but where they're all recycled is Europe. And also the European Union has a ban on importing tiles that are manufactured out with the EU back into Europe for recycling. So if there's any mixed ceiling tiles from other parts of the world in that mix, the European Union will not take them back and will just end up throwing them into landfill. So it's a bit of a process to recycle mineral fiber ceiling tiles, although it is possible. And one major red flag for mineral fiber in the use in hospitals is that the core of the board is actually a very good nutrient for bacteria. As I said before, we use cornstarch, which is a form of simple carbohydrate and sugar, and that acts as the binding agent for the core of the board as the adhesive. Now, a benefit of that is quite an environmentally friendly way to manufacture adhesive. It's low impact on the planet, but it is a nutrient for bacteria. So all mineral fiber boards that are put in hospitals should have an antibacterial coating placed on the surface on it to inhibit bacteria getting into the core of the panel. The next material we're going to talk about is glass and rock wool. Now, they have a couple of advantages as well. They're fire resistant. They have very high levels of acoustic absorption, sort of 8 up to 1, and they are moisture resistant. Pretty much all glass and rock wool ceiling tiles have an RH rating of 100 and are hydrophobic. And what that means is that when a water droplet lands on the panel, it beads away and is not absorbed by the core of the board like a mineral fiber ceiling tile would. Generally, rock wool ceiling tiles are composed of 75% recycled material, and a major benefit is the core of these boards have 0 nutrients for bacteria. So even if bacteria do get into the core of the board, they won't multiply and spread. They're also very easy to clean because of that hydrophobic nature. Dirt and water tends to bead off it, so they can be wiped clean and reinstalled back into the ceiling grid. Now, one of the major disadvantages of these ceilings is also their inflexible design options as well. They tend to just to be modular only, so we just have that issue with just designing white squares and rectangles. The disadvantages is that they're slightly cheaper than a metal ceiling, but more expensive than a mineral fiber ceiling for the same aesthetic. So you'd be looking at roughly about $60 a square meter to supply a high-end rock wool ceiling tile. Now, the next material that we're going to discuss is monolithic acoustic board. And what I mean by that is this is actually large format sheets of mineral fiber, which are coated with a fleece and are screw fixed onto furring channels, just like standard plasterboard would be. But they're topped with an acoustically transparent layer of screed to allow the acoustic absorption. So what that means is we get a flat monolithic look, just like a flush set plasterboard ceiling, but we have all the acoustic advantages of mineral fiber. So we can get very high acoustic absorption using these types of ceilings, upwards of 0.8 NRC, and we have attenuation of about 35 CAC and up. And as I say, no visible ceiling joints aids infection control in this because there's no joins, nowhere for dust, dirt, and bacteria to join. And it's great aesthetic because it's a flush set look. So very good for hygiene control and aesthetics. Now, the major disadvantage of this particular product, is it's expensive. It's $230 for material costs straight off the bat. But you will get sort of 10 to 20 year life expectancy out of this. So yeah. We're going to go on to our next questions, our last 2 questions. So what is the percentage of cost saving you can get by using a metal ceiling system over the other materials we've discussed here over a 20-year time span? So the options are 95% saving, a 20% saving, or 47% saving. So just have a little chance to think about that. And the last question is choose one option. Post-COVID design of the healthcare spaces need to be which? Multi-purpose, larger in capacity, or have bigger budgets? So what do you think, after the slides you've seen, what do you think would be the best way to design future healthcare environments? Would they be multi-purpose, have larger capacity, or need a bigger budget? So have a think about that. Well, thank you for listening. If any of the images of the ceiling systems were of any interest to you, please feel free to reach out to me further for any information. And if you have any questions relating to any of the ceiling systems that you've seen in here, they're all ceiling systems that Network Architectural can provide and help you with, and all ceiling systems that we've installed historically. So I will pass you back on to Brooke, and thank you for listening. Thanks.
Thank you, Stephen and the network team. I did say it in our last session. really cool facts in this presentation. It was one of my favorites. So such interesting questions coming through on the feed, different materiality, and some great discussion around designing for healing, the evolution of different sealing elements and different materials, and the benefits and challenges that do need to be considered. So we've got Stephen and Anna with us this morning, and they're going to go through some specific and some tough questions that you've sent through. But we will jump through the formal activity questions before we get into it. Thank you to everyone that's been putting their answers off on the feed to help everybody out. But let's go into it. Question 1, what percentage of the population in Australia will be over 85 years of age in 2050? I was watching that slide. We're going with 5%, right, Stephen?
Yep, that's correct.
Cool. Question 2, what will be the critical infrastructure that is required in hospitals of the future? A, digital infrastructure, B, hydrotherapy pools, or C, larger ICUs? I think we're going with A. Is it digital infrastructure?
Yes, indeed. Yep.
Absolutely. What type of data did Florence Nightingale use to develop her theories of nursing? And I'm going to go with B, statistical. She's the mathematician.
He was indeed.
Question 4, name 3 elements of biophilic design. Number 1, fresh air, natural ventilation. Stephen referenced this a few times, relationship to place and nature. And number 3, lights, natural lights if we can. Mm-hmm. Talk to me about this one a little bit further though, Stephen. What percentage of cost saving can you get by using metal sealing systems over the other materials over a 20-year time frame?
Yep. So that is actually 47%. And I know the initial outlay of metal sealing is a lot more expensive, but its lifespan is so much greater. I mean, the design life for a metal sealing can be up to 50 years. Now, probably won't ever make it that long, but with the other types of sealing types, they are easily damaged. So mineral fiber sealing types are probably on the outer after about 10 years. The rock wool ones probably about 15 years. And also with the metal sealings, you will more than likely get money back on that sealing when it comes to be recycled. People will pay you. It has an intrinsic value just now. So over the lifespan of a product, yeah, you'd estimate you'd save about 47%. And that's also to do with cleaning as well. The metal ceilings are a lot easier cleaned than the other 2 options. Yeah.
And a couple of interesting answers coming through for this one. Post-COVID design of healthcare spaces need to be A, multi-purpose, B, larger, or C, bigger budget. There was a few bigger budgets, wishful thinking maybe.
Yeah, that's good. We can always throw more money at it. We like that. But but multi-purpose, it's the flexibility, because after COVID, everything was changing so rapidly that the science wasn't completely 100% because it took everybody by surprise. So it was just that adaptability and flexibility of the spaces. So multi-purpose is good, because as we highlighted in the presentation, those Nightingale hospitals weren't actually used for their intended purpose. They ended up being used as vaccination centers. So yeah, you just have to be have adaptability in what you're designing these days.
Mm-hmm. So hopefully that covers the formal part. We'll jump into a few of our informal questions that are just coming through. You talked about the benefits of biophilic design. What type of sealing system is easiest to integrate? There was timber mentioned in there. There was metal in there. What's the type of sealing to integrate to best use those elements?
Well, timber is the most obvious one because it is a natural product, but most of the timber sealing products that you have installed are actually just like an MDF core with a sort of a face, either a laminate or an actual veneer, a thin veneer of wood strip on the face of them. But they tend to be really, really expensive and not used too much in hospitals, and they also have issues with cleaning and to be able to cope with the harsh chemicals used in hospital environments. So timber is a good choice, but it's a good choice for structural elements and decorative elements rather than actual sealing itself. Metal offers actually a really good biophilic sort of design capabilities, just because I think light and sort of connection to place are the two key things with biophilic design, and we have just so much more flexibility with the design elements using metal, and because we can pretty much customize metal to the nth degree. There's no limitation. So the other systems are fairly limited in what they can do. They're all modular, and they're all sort of white generically. I mean, they can be other colors, but they're just generally white and square. So you can introduce different colors on the other options and print them. But as we talked about, the biomimicry is when you try and create the outdoor environment by, say, using printing or graphics. And the human brain just picks up on it not being quite right, and so it doesn't really work. So I would say metal ceilings give you that flexibility of being able to bring that the outdoors, indoors, as it were.
Mm. And there was a few different ways to sort of create a ceiling, I suppose. Is modularity important in ceiling design, particularly when you start going into patient rooms or theaters? Access, saving, serviceability.
Yep,
Where
I saw
does that sort of sit?
couple of questions about that. Yeah, modularity is really good just for ease of installation. It's a really simple process. It's simple. The installers just click, and then they can start throwing in their products. So in terms of cost of materials and installation, there's a massive saving of using modularity with the other ones. But in saying that, though, metal as well is mostly modular as well and fits into a system. So yeah, the biggest thing about cost savings is all about repetition and just sort of repeating the same thing. So yeah.
Couple of questions, just particularly around metal, reflection of sound and getting that right acoustic mix. Would it reflect, or is it just the way we set it up is where we sort of achieve our acoustics?
Yeah, so sound is an energy, and it needs to be absorbed for it to be removed, or also blocked to stop it from spreading from space to space. So for metal to work, it's like timber. It needs a perforation in a hole in it to allow that sound to penetrate. And then you either have a small piece of paper or a mild piece of insulation behind it that does the absorption. So metal in itself is very reflective, and a solid metal panel would just reflect 100% of the sound, so it wouldn't work. So from an acoustic perspective, the metal needs to be perforated for it to work. Now, the advantages of the other systems, like say mineral fiber or rock wool or monolithic acoustic plaster, is it is soft and it absorbs the sound. So major benefit of that is you don't require any extra products on top of that, because that product is doing the sound absorption itself. So metal needs to be paired with something else for it to work, to give you those acoustics.
And I can see some beautiful coloured ceilings behind you in your photos there.
Yeah.
Colour in hospital.
Yep.
Ceilings, obviously different modular spaces to obviously create design. But how does the use of colour sort of affect those?
Yeah. Well, that's a really good question, and quite interesting, because traditionally hospitals are just generally white, aren't they? And one thing that's not really often talked about is that there's actually different cultural effects of colors as well. So white apparently in Asian countries is actually quite a mournful color. So people would wear white to a funeral rather than black. So white has connotations of death in some cultures. So that's something that's not well or often spoke about. But hospitals are generally designed as white just because it's easy to clean. It shows up dirt, and traditionally white was an acceptable color for sort of the Western world. So that's why we have generally white hospitals, and also white is actually a bit of a problem when you design a big infrastructure project like a hospital, because lots of corridors, everything looks identical. So wayfinding is a big problem in hospitals. You're already anxious, you're in a hospital, you're sick and getting lost and agitated and can't find your way around. So introducing different colors into the mix helps with wayfinding and knowing where you are, and just having a bit of a differentiation of space. also kids as well. Like there's images we showed you of that hospital in Hong Kong. Just a little bit of distraction, some nice color, some like elements and graphics on the walls help with kids when they're in hospital. So color has massive psychological effects on us, and it's something that's not really thought about. Everybody just chucks in a white panel in hospital. So with metal and the other products, we should think about color a lot more when we're designing our hospitals.
Absolutely. I always make sure to park in the red car park, and then I know I never get lost at the shopping centre. You mentioned cleaning. Is there a typical regime for cleaning systems in the hospital specifically, and different materials required, I suppose, different rotations?
Yeah, that's right. So most hospital products have certain guidelines of the materials, like they should be able to handle bleach and water and be cleaned. And all the products we've mentioned today actually can be cleaned with those. But what you tend to find is that they put dyes in cleaning agents to stop people drinking them, and that can stain things like mineral fiber and rock wool. So it's not the actual chemical itself; it's the dyes that they put in them would just ruin a standard mineral fiber or rock wool ceiling. Wouldn't have that effect on a metal ceiling. So with the mineral fiber and rock wool ceilings, the main advice is to be like brushed or using a HEPA vacuum. So that's a vacuum with a filter on it, and you essentially vacuum the top of the ceiling tiles. Whereas some mineral fiber and some rock wool can be hosed down and washed down and put back, but it has to be 100% dry before it goes back into the ceiling space. So metal has that advantage that it can be also manhandled a little bit more rough than the other products. So when you remove them, you tend to damage mineral fiber and rock wool tiles before you put them back in. So that comes down to the cost of industrial cleaning these. The cost of cleaning a mineral fiber and rock wool ceiling is probably double the amount to replace it. Now, obviously, sustainability-wise, you're better to clean it, but the actual costs to clean it properly and put it back is probably about double the price of actually putting in a new one. So metal doesn't have that problem. It's a little bit more robust. It can be cleaned and put back in. So yeah.
And speaking to cost or replacing, are there alternative uses for the ceiling products at the end of their life? Is there a guide?
Yeah, well, look, all of them can be recycled into their original what they were created out of. So mineral fiber can be put back into mineral fiber, but also, as I mentioned before, the clay component of that they're just basically clay bricks, so they can be separated down into their materiality and then turned back into bricks. The problem on mineral fiber is it's a bit of a process. As I mentioned, it needs to be certified. So you need the original manufacturer certification or receipt to prove where its origin before it can be sent back to a factory to be recycled. And generally, the cost involved to repackage ceiling tiles and send them back over to Europe it outweighs the benefit of recycling. So sadly enough, most of them are put in the bin. Metal ceilings are good because they can be turned back into absolutely anything. So tin cans, other ceilings, metal can be fabricated back into anything. So metal, people will, as I mentioned to you before, someone will pay you to collect that and remove it. Also, rock wool can be actually used as insulation bats. So if it's had its natural life of being a ceiling tile, you can use it as insulation to stop thermal loss as well. So there's some uses for that. So they all have their uses. Mineral fiber. I suppose the benefit of mineral fiber is that it's made from natural products like clay. So the world's never going to run out of mud. So it does have a very low impact on the environment because there's perlite in it, which is used as a sort of fertilizer in the ground and mud. So although it's not easy to recycle, it is quite a natural product. It doesn't have too much of an impact on the environment.
Interesting one around acoustics. Is there any difference in acoustic treatments that can affect patients of different ages differently? Is there different considerations in different areas or different zones with acoustic treatments?
Yes, yeah, no, that's a very good point. Also, as we get older, obviously we suffer from hearing loss, but what's actually happening is that your frequency of sound is diminishing. So when we're very young, we're better at hearing higher and lower frequency sounds, and past the age of 8, our hearing frequencies drop off. So that's an interesting one. So you've obviously got your different acoustic products that you can put in, soft things that absorb sound, metal panels. But one thing that's not often talked about is the room dimensions, the actual setouts of the room. So that can have a big impact on the frequency of sound, because sound is basically just like a wavelength. So if you have the ratios of the ceiling to walls incorrect, you can exacerbate the sort of mid-range noise, and that adversely affects elderly people more than it does younger people. So not only do you have to have things that absorb sound, you need to make the spatial, you make sure the ratios of the size of the rooms are correct. Now that's really, really technical, and we need to speak to our acoustic engineers, but they need to talk to the guys that are designing the floor plates and things like that at the outset, and that's very rarely done. The acousticians just talk about the materiality and what absorbs what sound rather than the sort of sizes of rooms. But that's one thing that we're not talking about. So.
Yeah, it makes total sense. Well, thank you, Stephen. That wraps us up. A reminder to everyone in attendance, please reach out to the network team for any projects or specific questions you have regarding ceiling design. Stephen has delivered some great information regarding healthcare today. However, the team have such a wider approach to ceiling systems across government, transport, land, air, shopping centres, retail, just to name a few. So Stephen's details will be shared with everyone following our series wrap up. So thank you to everyone again this morning. We have a short break. Our next session, grab a coffee. I look forward to welcoming you at our next session at 11:30 with LOHAS and presenters Michelle Park and LOHAS's engineer Andreas Pichel, and they're presenting the possibilities and designing with ceramics. And don't forget to follow on from that, our very last session for our last 2 days, CSR, the impacts of NCC, the National Construction Code 2019-2022, Section J on building design, including the impacts on thermal bridging on insulation requirements. And that is scheduled for 12:45. That's a great presentation as well. Thank you so much. I will see you soon.
Thanks a lot. See ya.
Thanks, Stephen. Thanks, Anna.